The channel. So today we'll be doing a binary tree question. So yeah, the idea is to identify the lowest common ancestor of the deepest leaves. So what does the deepest leaf actually mean? It means that let's say if we have a binary tree and we do a level order traversal on it, which means we go level by level, we have the leaves at the lowest level, right? So it's level 0, level 1, level 2, and level 3. So the leaves 7 and 4 are at the lowest level. And yeah, let's say if we had another node here called 9, then 7, 4, 9 will be at the lowest level, right? So the idea is to find the lowest common ancestor, right? Let's say for currently we have leaves at 7 and 4, and lowest common ancestor is going to be 2, right? But let's say if there was a node here from 6 left node 9, we will notice that lowest common ancestor is going to be 5 because there's nothing lower that is common to both 9, 7, and 4. So yeah, I think intuitively what I first tried would be to do a level order traversal, right? So the idea is to go down the tree level by level, and then uh, keep track of the lowest level and the leaves at that level. So how I did this is by using a level order traversal using a double-ended queue. I also keep track of the parents. So for example, for 2, 5, and 3, for 7, I'll keep track of 2, 5, and 3, 4, 2, 5, and 3, etc. So the idea is to refresh the current and nodes arrays. So these arrays the contain the parents of the current level and the nodes of the current level, and they refresh as we go to each level. So the idea is that at the end of the iteration of the double-ended queue, we will end up with a scenario where we get the parents of the lowest level and the nodes at the lowest level. So yeah, so this is the idea of how the double-ended queue works, right? So as an example, I printed out current and nodes. I used .val here so it's easier to see. So we can see that the two leaves at the lowest level are going to be 7 and 4, and the parents of these two are going to be 352, and 352 as well, right? This is similar for the other cases, right? Okay, so there are some edge cases for this question, right? So let's say if one example is what if the lowest level, right, only has one node, right? Which means there isn't going to be any lowest common ancestor because there are no other nodes to compare with. So we have to return the node itself, right? So for example, let's say if 7 wasn't here, then we just return 4, right? Another case is let's say if the tree is just the root, then yeah, it's just going to be the root itself. So yeah, that's why we return the root, right? So let's see the idea of how we find the lowest common ancestor using this array, right? So we iterate backwards. So we pretty much have to reverse every parent array, and then we have a set mechanism here such that we can identify which is the first element at which the intersection between all the sets for all the different leaves becomes greater than 0, which means that there is one common element, and this common element is definitely going to be the lowest common ancestor as we are iterating backwards for each leaf. So yeah, so that's how you solve the question, and thank you.